So I think we're ready to start.
I think so, yeah.
Let's get going then. My name is Dale Lutz, and I'm joined today by my friend Dave Campanis.
Hello.
Here in beautiful Surrey, British Columbia, and we're also have Mark Ireland tuned in, not from the UK, but where are you, Mark?
I'm in a place called Killarney in Manitoba.
Where it is a toasty minus 43 outside, so that motivates you to stay inside and work on interesting FME things, I guess.
It does, it does.
All right. So we need Mark to advance the slide.
Oh, absolutely. Sorry.
There we go. So today we're going to be talking about CAD and GIS, and specifically the AutoCAD family, Autodesk family of products. And we're going to be doing that by doing primarily a bunch of interesting live demos. So let's just storm through these intro slides. I already did some introductions. I'm one of the original founders here at SAFE. And Dave, what's your story?
I'm a product support specialist. I help people solve their problems with FME, basically.
And before you joined here, you in fact also used FME to solve your own problems, I guess.
Yes, I do. I've been using FME for over 15 years now, I believe.
Wow, that puts him in one of the early ones. And Mark Ireland, what's your story?
I used to be a land surveyor in the UK, and then I moved over and joined SAFE.
Excellent. And then eventually wound your way from Surrey to Manitoba.
Manitoba, yes. And I'm the product evangelist, so I like to tell everyone how great our stuff is, and I do all the training materials as well for SAFE.
Yes. And speaking of training, in a few minutes here, there's a training course starting up next door. And in fact, we're going to be mentioning there's even one that starts tomorrow if you want to tune in. All of our training is online and free. So we have live broadcasters who, and we give you an Amazon machine, and you can go ahead and use that if anybody wants to. And you can sample Mark Ireland's fine training work in that way. Tomorrow is actually a raster class. We've also got others from our team of mostly faced professional services. I see James hasn't sat for a photo shoot yet.
He's in the witness protection.
Okay. Okay, well anyway, sorry James, we need to do something about your photo, and we'll get our top people on that. But otherwise we have Dan, Mark, and James. Please keep them busy. Fire in the questions. They're standing by to answer. And whatever we can answer today, we will follow up afterwards with. All right, wow, we're going right to the polls, and that's my job to initiate the polls. And so we wanted to get a sense for our audience to understand what parts of AutoCAD or the Autodesk family do you use. And so we got the people are voting right now. You can choose more than one. The one thing that isn't in here are the new 360 services. And at the end, we're going to ask about that. So if you are using the 360 services, please chat that. So like Autodesk 360 or InfraWorks 360, those sorts of things. Otherwise, we'll close the polls in just a second. I got a magic threshold I'm looking for, and I think we've just hit it. Okay, so I'm going to close the poll. Quickly get your vote in if you're going to. All right, and we'll share those results. So, my panelists here, how are we doing today?
Wow, there's a lot more Civil 3D than I thought there would be in there.
Yeah, lots of people like Civil 3D. Did you prep a demo on Civil 3D, or maybe while Mark Ireland is doing his presentation, you can get one whipped up?
Yes, I have actually prepped one. That's not something you whip up in a couple of minutes.
Okay. I'm sure someone must have some Civil 3D data around here we could have used. Yeah. Anyway, that's great. Thanks for tuning in. Lots of Map 3D folks too. We do touch on Map 3D, but we could do a whole webinar just on Map 3D because our support of object data is very rich. Do you remember, Mark Ireland? We did one once just on Map 3D object data.
I believe we did, yes.
Yes. All right. So let's go back to the slides. And just a few words about SAFE. There's almost 100 of us here. We're represented around the world. We're in beautiful Surrey, British Columbia, where that little dot is on that map. And where you have lots of customers all around the world, most of whom are happy most of the time. And when they're not, that's where Dave and Mark and the rest of the support team come in.
Yes, we try to make you, if you don't come in happy, we try to make you leave happy.
Yes. We sit in the middle between lots of different data types. Today we're primarily sitting up in the top there of our diagram between CAD and GIS. That's where we're going to be. But we do support things like point clouds, and we're going to do a little BIM. You've whipped up a Revit demo, have you?
We've whipped up some Revit demos.
You aren't going to whip that up while Mark's presenting, or?
Oh, no.
Okay. Okay, so we got that going, and we can do all kinds of things as we're moving data, not just translate it. We can rearrange it, integrate it, validate it. CAD validation is a big thing. And actually, you have something, you're going to whip that up too?
There's a little bit of CAD validation, so I'm going to sneak into one of our other demos.
You know, at Autodesk University last week, I attended an excellent talk by David and some others from Coal Pipe, I think is the name of the place, talking about CAD validation and specifically how they use FME to validate drawings. So a big use case, a packed room, and a lot of interested folks, some of whom may be tuned in today. And if you're tuned in from AU, thank you so much for joining us.
Okay.
Oh, we're going back to the polls just to see how much people know FME. Dave would answer in the 4+ category.
Oh, yes.
And we got lots of votes pouring in. Quite a good spread of users.
Excellent. Well, we'll show the basics today, won't we? And right
Yes.
up to the more complicated stuff. So hopefully something for everyone.
Yes. So I'm going to close the poll there and share the results. For, I think, the first time ever, the plurality, so if this was the first past the post system, which I know, Mark Ireland, you're very excited about that system of voting, that would mean the not yet FME users would be our representatives today.
Wow.
Using the polling system we have in Canada, the UK, and I think a few other places. So anyway, thanks so much, new FME users, or not, I guess pre-users, pre-FME users, for tuning in. This class will be fairly, or webinar is fairly fast-paced, but if you're brand new to FME, we really recommend you tune into these two fine-looking gentlemen who will be broadcasting tomorrow, I think. Yeah, Thursday. So if you go to that page, FME Getting Started, or the weekly webinar page, you can join up, and then they'll take you a little bit slower through things. Although, Mark, you're going to go through from basic principles pretty much.
I am, yes.
Excellent.
And there's tutorials and training on our website as well. So whenever you need
Yes.
any help like that, yeah.
And if you're brand new and for some reason are an AutoCAD and raster user, you can sign up right now for the free raster training that goes tomorrow.
Yeah.
There you go. All right, so let's carry on. Right, just a few things to say about CAD and GIS and why this is such an interesting topic. It's because it's a little bit like fitting a square peg in a round hole. And sadly, it is a square peg in a round hole that lots and lots of organizations want to be fitting together all the time. And there's lots of historical reasons for that. Traditionally, the CAD packages have had a bit of an advantage as far as data collection platforms, especially historically. That results in a very trained workforce that knows how to do things in CAD. Mark, you were a CAD guy in a previous life, weren't you?
I was more MicroStation than AutoCAD, but
Yes, but you're bilingual now, I guess.
I am, yes.
Right. So the issue with CAD people is that they like to fit things into the drawing tools that they've got, the levers they can pull within their file formats, which tend to be very weak when it comes to attribution. Now, I did see that more than 50% of the people tuned in today were either Map 3D or Civil users. They have more attribute options available to them, but traditionally, people did all kinds of crazy things hiding attributes into CAD. Some of my favorites were things like, in MicroStation side, hiding a database link into the Z or Z, min, and max value of a 2D DGN file. The Z, min, and max were in there. People thought, hey, those are an extra 4 or 8 bytes. Let's put a database key into there. So that's one of the crazy ones. On the AutoCAD side, I don't know if we've got folks tuned in from Southern Company in the US, but years ago we helped them do a big CAD to GIS migration, and they had done, in my opinion, one of the most clever things I'd ever seen, and very well enforced layer naming schemes, where in the 32 characters or so, I think you got 32 characters for a layer traditionally. Does that seem right?
I don't know. I too am a MicroStation guy.
Okay, wow, we got infidels here today. So anyway, I think someone on there would know. I believe you had 32 characters. Bottom line is they carved that up into groups of 3 or 4 and said the first 3 characters are going to be the material type. The next 3 characters are the permitting key. The next 3 characters are this. So they had these like literally thousands of layer names in their drawings, which were all the combinations of these attributes which were encoded into the layer name. And so we were able to pick that apart and put it into a arguably more sane model in a GIS. The GIS, of course, you have true attributes, a relational model. You can do more analysis around networking and things are closed or not, and connectivity. Coordinate system, a big deal. CAD people typically don't have a coordinate system unless they write it down on a piece of paper, whereas the GIS people typically have to have one. So there's lots of differences to deal with. So when we're working with this kind of thing coming through our approach, we say let's preserve all that we can. Let's give you, as the data jockey, all the information that's possible in the CAD and give you levers and ways of pulling that out and putting it into same things over on the GIS. So we can interpret the layers, we can get out the style number. Oh, if it's a green road, that means it's a logging road. Great, we can do that. We can fish all those things out and rearrange them very painlessly along the way. Now, CAD to GIS is what we're talking about. You might go CAD to CAD, where all your outputting are the things that don't follow the spec. And you give back a CAD file to your technician, and he says, okay, great, if there's things in here, I got to fix them. These are the things that can be done. Or are we doing a bit of, I think we're doing dog parks today, aren't we, Mark, where we're going GIS to CAD?
Yes, we are. Yep.
So that we can go the other direction. You've got a nice GIS. You want to take and make some files in CAD for your friends and even give them some symbology. And I'm going to dare you, Mark, to show the DWG styler. Are you going to take me up on that?
Oh, yes. We'll use that one for sure.
You whip that up while I'm talking? Okay, great. All right.
So that's a key transformer. We'll definitely look at that.
So just last quick poll. What are your biggest problems that you have to deal with? And this is where Dave is going to whip up other demos, I suppose, depending on what they answer. That was a really good worried look on his face just now. So let's see what kind of challenges. It's attributes, attributes, attributes. It's kind of like the 3 things you need to know for real estate. That's what I think too. And coordinate systems are always a lot of pain. I guess with the new FME data inspector, we could at least help you by, you could tag your CAD file with the coordinate system and put it on top of a background map and see where it lies to try to guess things.
Yeah, that's actually a very good technique.
Yeah, maybe I'll get you to whip up something like that, Dave. I don't know if we were going to show the DI. Were we going to show the data inspector?
I believe Mark is going to show the DI.
Yes, we'll show that.
Do you have a background map there, Mark?
I can put a background map on for sure, yeah.
Well, you can whip that up in about the next 10 seconds between now and when we go live to you. So let's close the poll, and I will carefully analyze those results while Mark gets his demo ready. So overwhelmingly, it's about attributes. And so we will spend some time on that, and I will throw in a few comments of horror stories and symbology going the other way. So the dog parks kind of thing, the DWG styler, big deal. And the object data people are in the minority, so in our system of voting, they would not get representation at all. But we are going to try to give them at least some airtime today talking about object data. And I would like to just do a whole webinar on object data, and I may just do that under the FME Files banner sometime. Would you be game to be part of that, Dave?
Always.
Good. All right, so with that, I think, Mark Ireland, we're going to let you take it away and give us some demos. Going CAD to GIS. I'm going to kind of, whoops, we just hide those results.
I just did it, yep.
There you go, Mark.
Okay, well, yeah, we've got a lot of demos to get through, so we'll start very quickly, or as quick as we can. So what we're looking at here is a product in FME called Workbench, and you'll find that there's several applications that we have in FME, and Workbench is the key one for translating data from one format to another, which is really what we're all about. We're all about translating data and transforming that data as it's going to try and get the data into the system in the way that you need it, where you need it as well. So what we're going to do first is just generate what we call a workspace or a translation from one format to another. And we'll start out doing CAD to GIS. And in this case, we're going to go map 3D, so we just define the format of data. Let's browse for some data. That would be in the water folder, and we have distribution. And so we can pick a format to write to. In this case, I'm going to go to Arc Objects, and I'm just going to suggest a place to put this. Let's put it on C drive. I'll pick an output folder and we'll call it water.gdb. So that's as simple as it is, really. We open up this dialog, we say let's go from AutoCAD, let's go to Geodatabase, for example, and you can see in this list here that we support, how many formats would it be now, Dale? Would it be...
Mark, I think it's over 300. It's close to, and Mark is actually showing FME 2014 here.
That's
and
right.
we are close to 220 different formats. So it's a very substantial number.
Yep. So that's fairly straightforward. I hope everyone's seeing this. A couple of folks said they can't see anything going on. Okay, so what FME's done is it's scanned that source data. It's come up with a list of layers in that data, and it pops up this, what we call a workspace, which is basically a translation. So on the left hand side we have all of the different layers and everything, and on the right hand side we have all of the tables that we're going to write into Geodatabase. And this geometry filter is because this is what we call a transformer, and FME has thrown that in there automatically because we've got data there that's in two different types of geometry, and Geodatabase can't handle that. Hoping that everyone can see what's going on. I see a few people can't, but I'll just keep going on, and someone let me know.
It is working for most everybody. I think there's just a couple of folks.
Okay, that's good.
Yeah.
Okay, so what I'm going to do, I'm just going to disable one of these outputs on the table because I don't really want that. Whoops. Control E and disable that because I just don't want that table out there. I'm just going to stick with the point features. Now, one of the key things we really should be doing is inspecting the source data to look what we've got before we start to translate it, because that's one of the things that you really need to look at it before you translate the data, and then you know there's no problems with the information. So what I'm going to do is right click on my source, and there's an option here called Inspect. And what this does is pops up the another application in FME called the FME Data Inspector, and that lets us look at the data before we translate it. So I'm just going to click OK and take a look at this. And I don't know if I've got a background map turned on or not. Obviously not, nothing's popping up, but you can see the information, you can see all the three different layers of data we've got and how many features are on each of them. I can zoom in and start looking at this and finding, well, okay, we've got water meters of these numbers, which presumably is an ID, and then we have water distribution pipelines, which has got a diameter and a few other excuse me, a few other characteristics and attributes on there. And then we have these little cross symbols, which are basically exploded blocks, I think, representing the nodes in our water network. So I'm looking at that, and the data's looking okay. It's okay to go ahead and do the translation here. Let's just do that, since Dale asked about that.
So here's where we're going off-roading, huh, Mark?
Yeah, see, I do have the background maps turned on. I wonder if that data doesn't have a coordinate system set, and that's why it's...
And yes, we can tell that
so
the coordinate system is unknown from your feature information window.
Yes.
So
that's
yeah,
right.
so
It should say somewhere...
It does right where there.
System unknown. Okay, so looking at the coordinates there, and knowing what I do about this data, I'm going to open it again and specify that this is in TX83, Texas State Plane, in feet, and now it should load a background map. I'm hoping.
Yep, it's coming in.
There we go. So this is new for 2014. We've got the ability now to load background data from web services directly into here, just to make it a little bit easier to to get an idea of the data itself.
So I guess if folks don't know their coordinate system, they could use this and then start guessing a few and then overlay it, and when it sort of lines up, then, I mean, I'm sorry that it's not more magical than that, but right now that's about the best we can do.
So okay, we can see the data, we know that's fine. We've got this translation set up in Workbench, so I'm going to hit the run button.
While you're on there, Mark, people have said, the few that had some troubles say that if they log out of GoTo and come back in, then all is well, all is forgiven. So,
okay.
And if you've missed some, the recording will be available later, so you'll be able to hear every and see every last pixel move.
Okay.
Ooh, and you wouldn't want to miss the translation log, would you?
Okay, so the translation log told us that we read how many thousands of features and wrote. So we read 5,240, we wrote 3,348, and the reason for that is because I disabled one of the output tables because I didn't want that. So that's why we're writing fewer features than we're reading. So we've got that in Geodatabase now. So what I can do is just browse to that data in ArcMap. I'm probably going to need to refresh this and look in the output folder, and there we have water GDB. So we've just basically translated that. Let's not bother with meters, let's just get the nodes and the pipes. So there we go, we have data that we've translated across, and if we query that, if we've got a query tool, we should get the same set of attributes that we did before. So it's the annotation, diameter of the pipe, and all of the statuses and all of the other attributes in the material. All of that.
So that was Map 3D. That was Map 3D object data that you fished out of there.
That's right. Yes. And just to mention Map 3D, if I've got a moment. See, when we open a dataset or read a dataset, you might have noticed the parameters button. If I click on a parameters button, that lets us group our data in different ways. So we can group it by entity or by the object data table itself. So in this data, we've grouped it by the 3 different layers we've got, but we could group it by object data as well if that was different, or totally the raw relational tables. We could just read all of those out separately if we wanted to.
Yeah, it's very powerful, and folks can do very powerful things with the object data in Map 3D. If you're not a Map 3D person, and let's say you had extended entity data that you tucked stuff into, Mark, have you ever dealt with that?
Yeah, we can read extended entity data through the plain AutoCAD reader, as well as probably the Map 3D one will do that as well.
Yep, we've seen a lot of data tucked away, and if also people often use some form of database linkage where they have the attributes sitting out in a database, some kind of a key inside of the CAD file. What do we do then, Mark?
That would come up as what we call a format attribute. So
yes,
if I query
and then we
something,
can use. Oh wow, there's Texas. You got all of Texas here for us.
Yeah, I just wanted to show this because this was a Map 3D data set, which I really like, because the thing about Map 3D is you can share lines. Like the edge of the state can also be the edge of the county in here. And so that's what this Map 3D data had. And what we've done, we've pulled it out as the Map 3D table. So basically we should have 2 lines there now. So we converted that one line into 2 features. So now we've got a feature there for the county and a feature for the state boundary. Or we could keep the 2 as one single line with attributes that said it linked to both.
Right,
So
I can see in your feature information it shows you got 3 things selected. Can you just pan up to the top of that so we can see the feature types?
Yes.
There's
So
the boundaries.
That's the boundaries, that's the county data, and the state
Right.
data.
And that's those tricky Map 3D guys end up storing that as one thing, but the GIS guy might need that in 3 different places.
That's right. And we can still do that as a single one. I think group by entity, will that
I
keep
think
it
so.
as-
We'll then merge all the attributes on.
Yes,
to
so
one.
we'll keep it as one single feature, but like you say, merge all of the attributes onto the same one. So
Yeah,
there we
only
go.
one
So
guy
that's,
there.
That's everything, but you can see the layer says boundary. There's also state and county data, so we know it's everything.
And it's got the attributes. I see the state is Texas, the county is
Yes.
there too, and
Andrews County, yes.
yeah.
So there's
Excellent.
several different ways we can read the Map 3D data, which is I really like that reader. I think it's fantastic.
It is dangerous though when you're messing with Texas like this, Mark.
I'm not messing with Texas. We're just... Okay, so let's go for another demo. What we'll look at here is doing a bit of transformation of one of those strange scenarios that you were talking about, Dale, with the in this case what we've got is the attributes are stored as pieces of text or labels, and we basically need to find those labels and attach the information onto the features itself.
Ah, the old label gag.
Yep. So we're going to read just some plain AutoCAD this time, and it's the wastewater. And we might as well go to Geodatabase again, and we'll just say to overwrite that Geodatabase so we don't copy it the same way. And I'm going to shut down our map as well, just so we're not got that locked in any way. Okay, wow. So what have we got here? Well, let's have a look. I think perhaps I generated that slightly wrong. Let me try that again.
While you're regenerating, someone asked if we can write to object data, and absolutely, and we can write it in very powerful and interesting ways. So that'll all be part of that webinar that Dave's whipping up for me to broadcast soon.
Yes.
Okay, so that, hey, that looks cleaner, Mark.
Yes, so there we go. So it's through the geometry filter in, which is really useful actually in this case, because the lines and the text, if I go and inspect this data, we'll find that lines and text are all on the same layer. So we have to filter them apart with the attribute, the
so
geometry
they're
filter.
Living together.
Yes, they're all on the same layer, and the size of that pipeline is stored in a piece of text that's right next to it, which is a typical CAD thing that I've certainly seen that before. So what we need to do is basically, in fact, yes, so users have used FME before. I just mentioned this. In 2014, the geometry filter doesn't have the long list of geometries. You get to pick which ones you want to expose. So I just mentioned that as an upgrade to for 2014. We'll just mention that. Okay, so we're going to put what we call a neighbor finder in here. And the neighbor finder...
Can you handle that spelling of it, Mark?
I can do it in both ways. We can do neighbor finder with a U or without a U.
Okay, so
it should have a U, but I know. Okay, so the lines are the base, the text is the candidate, so we're just going to grab that. Okay, so what we're going to do now is say, let's find everything that's within 50 feet of the pipeline. So that's basically saying where, for each pipeline, look within 50 feet of it to find the nearest piece of text, and we'll assume that that is the size of the pipe. And
so it's going to merge the text attributes on.
Yes, that's right. In fact, what I'm going to do is I'm just going to I'm fiddling it here a little bit because I made a mistake and started halfway through. Sorry. Anyway, so
this is like a cooking show. So we're back from the commercial break, and you've just done a tiny bit of.
This is one I created earlier because the one I created earlier has actually got a proper schema on the output, which I want to keep. So let's keep that. So what we're doing here with the AutoCAD text. So this is AutoCAD text string is what we call a format attribute, and that stores the information from the text string that we grabbed using the neighbor finder. And what we're also going to do is store the AutoCAD color, because why not? We might as well keep that original color, just so that if we convert back from, say, MapInfo to or Geodatabase or whatever back into AutoCAD, we'll know what the original color of that data was.
So you're basically making two copies here. One's going to, oh, I see, you're going to two output things at once.
I am, yes. So I thought I'd write to MapInfo and KML at the same time, which is a perfectly legitimate way of doing it in FME. We're certainly allowed to do that.
As long as did you identify the coordinate system at some point?
Now, I don't know that I did. We should certainly identify the coordinate system on the source, which was
because you'll be out of luck on the KML side.
Yes. So we need to tell it the coordinate system on there. If we want to reproject it to a different coordinate system, say in a MapInfo, we can surely do that. We can just click on that setting and say what coordinate system do we want, and we can say UTM 83. I'm not quite sure the zone for Texas, but we'll say 10. Which
You're
I think
messing
is-
with Texas there, Mark.
I am. I'm certainly messing with Texas this
I
time.
think you've
I'm
moved
gonna-
Texas into Vancouver with that.
I think that's the
zone, but-
BC coordinate system, but
Well, let's see what
anyway.
happens.
Anyway, we can pick any coordinate system, and again, we support several hundred coordinate systems. So,
Actually, thousands.
thousands. Oh, well, there you go. So wherever you are, we've got a coordinate.
U.S.
system to
Albers is
match.
probably safe. Type in U.S. Is it called U.S. Albers?
Albers.
USAK, something like that.
That's
Sure.
Alaska, isn't it?
Maybe okay. Well, maybe we don't.
Now
want
you're
that.
really messing with Texas.
US 48. There we go.
US 48. Okay, we'll go with that.
Nothing bad will happen.
And we don't need to set the coordinate system on KML because FME will automatically translate that into lat long, because KML is always lat long. There's no two ways about that.
So notice that when Mark runs, we see a statistical breakdown on our graph about what happened. So 862 things read in, split into 496 and 366. And then you got matches on 458, which means you didn't get matches on a bunch of lines. If we were worried about QA things, we would then look for unmatched base, which
That's
is right now
right.
being ignored. And you could do something with that. Send that back to your CAD guy and say, hey, label these, dude.
So that will be the 40 features that didn't get labeled, and we could check where text wasn't used, unmatched candidates as well. We could say, well, this label's floating in midair, and we don't. Yeah. And so let's just inspect this data. It was map info. I ended up writing it out to, and we get the background map, which is good because that shows it's in a coordinate system. And it's in US 48 coordinate system, and you can see we have the attributes in there, the pipe diameter and the original color. So we've grabbed that information out of the AutoCAD data.
Mm-hmm.
Okay, so I think, Dave, you were going to do a demo now of Civil 3D, is that right?
I think we're going to do a little bit more and show some of the validation we can do. In,
Oh, okay.
Sure.
Sure.
Against the table.
Okay, well, we can do that. Yeah, I mean, we can, because we're reading out all of this data at the moment, and it's all coming in on the same layer. So I guess what we could do is we could put a tester in there to see. Well, what we can do is we can set a merge feature type, which says basically read anything on any layer, and that will handle the data. If someone's put something on the wrong layer, it won't matter because it'll come through here, and we can still read that data. So that's handling it just in case all of the data's on the wrong layer. We could put a tester in here and say, well, let's test if, I don't know, test if it's the wrong color or something. So we could say, well, if the AutoCAD color was this, then do something. So that's a good way if the data's all been color coded, as I know it does get sometimes in CAD data. If you've got data, it's all on the same layer, but the color means a different thing, then we can start filtering that data out. Finding splitting it out by color. Geometry we can validate as well. We have a geometry validator transformer. So in fact, why don't I just run that with a geometry validator, and we can run a whole bunch of tests on here. We can set a bunch of custom tests and say, does it self-intersect in 2D? Is it missing textures? Is it got not a number problems anywhere? So we can just say, let's test against everything. And so we've got the past, and we'll say, did we tell it to repair the data? Yes, so we said, repair the data if you can. So we'll say, okay, all the repaired stuff can go through, but if it failed, then we'll connect it to a logger transformer, and that'll get written out to the log, so we'll know which data didn't pass the validation. And in this case, we've passed everything, so that was good.
I mean, another thing you could do with that stuff that didn't pass, again, is add another output. Mark, in this example, already had map
That's
info and
right.
KML going out, but you could have another DWG file going out and then send the
That's
failed
right.
to that and send it again back to the CAD technician.
Yeah, very simple, just to create a new layer in the output, call it bad data, and the data that's there will get written. And we can do the same thing with that unmatched base as well. If there's some data coming through, we think we've got 40 bases that didn't match, so we'll just say unmatched pipes, we can call it, and that data will now get written out there when we run this translation. So yeah, 38 features now. So we know by inspecting this data, it's in KML, that's fine. So where are we? Unmatched pipes. We'll just turn the background off. So you can see these pipes are the ones that didn't have a label close enough to be matched.
And all, of course, their table shows that all the pipe diameters are missing.
That's right, yes.
So let's switch over to Dave now,
Okay.
and we'll make him the presenter. And there you go,
Okay.
Dave. And
Okay.
Dave has done another slight addition to this, where it might get tedious if you have lots and lots of things to validate. You could put the data or the validation rules out into another table. And so there you go, this kind of an idea where you've got this table that lists the valid diameters in your case, right?
Yeah, I just essentially picked the diameters we had in this case and removed one just to see that it would work.
Right.
So I'm reading in the CSV table using the CSV reader down here,
Yeah.
and we run it through to a feature merger. What this is going to do is it's going to merge the diameter of the CSV file against the text that we've read off of the label, and it's just going to make sure it finds a match.
Right.
If it does find a match, merge, it will go to the output. If it doesn't find a match, we'll just log it in the log file for now.
Right.
So let me just take a quick run. And okay, that's unexpected.
Unexpected, but we won't worry.
We won't worry. We're on a short time, but essentially, yeah, it will.
When there's red in there, it means that the demo isn't working, so we'll just hit stop.
Yes.
And we won't worry. But the concept is that you can outsource the rules into an external file, like a CSV or a database. It's a very common thing, an Excel file often.
Yeah, and I gave a very simple example, but you could test against the different diameters. You could test against combinations of say a certain diameter has to be on a certain level, or say a certain road has to be on a certain level, or the colors have to all match. And if you get data that doesn't make any sense, you can then kick that out. In this case, I just logged it, but you could also kick that out to an Excel table as well.
Yes.
With some information about the feature, so your editors can go back and fix that. And you can actually sort of set up set up a sort of round robin where you run the QA, and then the editor goes through, and if anything in the Excel file is valid, even though we flagged it, he clicks a little valid box. Next time you read that Excel file as well,
Yes.
and then you can ignore the errors, and then it helps your editors consistently get a good product.
Right. Okay, so what other things are you going to show us today, Dave?
I'm going to show you the Civil 3D import into FME and some of the things you can do with it. First thing I should mention about Civil 3D is we have a number of Civil 3D features that we read, but we don't yet read all of them.
Right.
So these are a list of the ones we do read, alignments, parcels, sites, etc. And this is in the FME help, lists everything that we can read. However, but let's switch over to a...
And again, to be clear, it's Civil 3D 2013 and older. We don't yet do 2014.
No, we don't do 2014
But we got top people working on it.
Exactly. So this is a sample Civil 3D file. Again, we're not going to be able to read everything in this file, so I'm going to concentrate on something that's useful to the plumbing guys, which is pipes. So we have a pipe here, and it's got some interesting information on it. Most importantly, it has invert elevations on it. It's got 2D lengths. It's got a slope on it. Things you sort of need to know when you're designing drainage systems. So we're going to bring this into FME, and the first thing I'm going to show you is when you read a Civil 3D file into FME, you have an option to just read the Civil 3D entities only, or you can also read all of the Civil 3D and CAD entities. Now, a lot of cases, people build up a Civil 3D by bringing in CAD data and then manipulating it so that you build your proper structures and everything. So we can grab, like I said, just the Civil 3D data, or we can grab all your construction data as well. And the construction data is read in similar to it would be read in, I believe, in standard AutoCAD. So as layers, etc. Let's see, we probably want to expand blocks off, and you have all the other options that you normally would have with AutoCAD import. So we're going to cancel this, and I'm going to go to, like Mark did, I'm big on the whole canned cooking show type thing.
We're back.
Yeah. So this is a workspace I've made to bring in that information from that Civil 3D file I showed you into FME.
And what what Dave has done for those new to FME, you've spent a little bit of time making this nice and pretty so it would be pleasant to look at or have hanging on your wall by using bookmarks to color the different themes you're dealing with.
Yes, and I also find that that really helps if you created a workspace and then you go back in 6 months and you're trying to figure out what you did.
Right.
I'm getting to an age where I don't remember that so well anymore. So I find tools like this sort of aid your memory, and it does look pretty if you're trying to impress your boss too.
I'm impressed.
Okay. So for the basic features we're reading in, the sites, the parcels, they don't need really much manipulation done to them. All I do is I rename a few of the attributes to go from the information, the names we get in Civil 3D, which are maybe not the most explanatory of names, into something that is more suitable for an ArcGIS output, for a GIS guy to understand. So here we have the site, we have the parcels, things like parcel numbers, structures, which are like manholes, etc. Now we get into something a little bit more interesting. Now the COCO points, that's the point layer, and let's see if we can see those on here. Okay, those are not showing up.
Who knows Civil 3D?
All points. Well, they're turned on, but I can't see them in here. But trust me, they're there. The cool thing about the points, though, is that they're divvied up into things like spot heights and trees and some things I couldn't figure out because I'm not really a civil engineer. So what I did is I grabbed the information I did understand, and I'm using a series of transformers here. The first one is a string searcher. It extracts all the trees based on a search string. Essentially, if it's in the style it says tree, I say let's go for it.
Followed by a C or a D, it looks like.
Yeah, so it's labeled tree coniferous or tree deciduous. And the other cool thing is I take by putting that little C and D in the brackets there, I also extract the type. So I've now extracted all my trees into a separate feature, and I've extracted the type of the tree into its own separate attribute.
Yes.
It's kind of a 2-for-1. The next thing I do is I'm looking for the diameter of the tree, and that's stored in the description, and the description will say 340 millimeters or something. So all I want is the 340.
Yeah.
So I use again another regular expression to extract that into a diameter attribute.
DIA. That's also stands for Denver International Airport.
Oh, okay.
Yeah.
Which is probably snowed in right now. So after I've extracted that diameter, I rename it to. Now these matched parts, they come out in a list structure.
Yeah.
So I take the first element of the list, I name it to something useful, which is diameter.
Although Denver International Airport is pretty good.
That's true, but we don't want people getting confused and landing on a tree. So the next thing we do is the tree types. I extract C or D. Now that's not a lot of information. Let's make it a little bit prettier. So I mapped that using an attribute value mapper to conifer or deciduous.
And so if folks, I'm not sure if you're going to Geodatabase here, but if you were going to Geodatabase, that could even go into something that was domain over on the Geodatabase side.
Actually, yes, it could. Yes, it could. We could set up a domain and have that mapped on the output. So that's their COGO point. So basically, the other thing is I test the ones that weren't trees, and I just do a little test on them and see if they're actually spot height.
Okay.
So I extract those to spot height. So I've got spot heights, COGO points, which are ones I don't understand, and I have trees, which are divided up into coniferous and deciduous. That's for the COGO points. The next step is alignments, the road alignments.
Just one last thing on the trees, Dave.
Sure.
Can you pop open the properties on the output feature type by hitting the gear button there?
Sure.
So at some point in the user attributes, Dave would have added the diameter in there.
Yeah.
You had basically gone and entered in the structure that you wanted. If you already had a geodatabase that existed, you could have pointed FME at that and sucked in the definitions. Yeah. But just so people know that you have control over these things if you're going CAD to GIS.
Yeah, one caveat to that is if we are creating the table in the geodatabase from scratch, FME will create that table to fit the schema that you set here.
Yes.
If you're writing to an existing table, we will essentially write to that existing table. We do not have to have power to alter the table.
Right.
To add. So if you add an attribute like the diameter and you're writing to an existing table, it will unfortunately disappear.
It'll just bounce off and we'll ignore it, and probably a little warning will be there. In any case, what else do you got in here for civil?
Alignments, which I believe has something to do with roads. This is pretty much simple in that they come through as an aggregate of lines and points. I extract. Now this is kind of interesting. We have attributes in AutoCAD, but we also have a thing called traits. And traits is a fancy word for an attribute that's stored on the geometry rather than on the feature header itself. So in some cases, if you have multi-level geometries, you can store, in this case we have lines and points, and in this case we have attributes that are stored, I believe, on the line section of the geometry.
Yeah.
That we want to extract. Next, we go to a geometry filter where we split the points from the lines, and then we rename the attributes that we've extracted into usable attributes in
Okay.
GIS.
Yeah.
So that's a little bit more processing. Now the most processing kind of goes on here in the pipes. And one interesting thing, if we switch back to the pipe information, is they have these start invert elevation, end invert elevation. Well, the sneaky thing about Civil 3D is it tells you information it doesn't store. So in this case, the invert elevations are not actually on the pipe features as they come through. What they give you is the pipe centerline elevation and a pipe diameter. And from that, you can calculate the invert height and the crown height as well. So essentially, that's just what I've done here. I've got a length calculator, which calculates the length of 3D. I renamed a few attributes. I rounded off the attributes to the nearest 3 decimal places to make them prettier. And I extracted the beginning elevation and the ending elevation, and then I used the attribute creator to do a bunch of calculations in there to calculate the invert elevations as well as the slope.
Okay.
So from the length and the elevation difference between the beginning and the end, you can actually calculate the slope, and that's what Civil 3D does when you click on that to give it the information. So again, that's something we have to reproduce, and we can reproduce quite easily within FME.
Because this way you can tell that your water flows downhill.
Exactly.
Okay.
It's very important because it's not all water.
So what do you do then? This is the resulting output you're going to show us?
Yeah, this is the resulting output here. So
This is an ArcGIS now, Civil 3D to ArcGIS.
Yeah, ArcMap. So here we come out. I've just thrown a few symbology settings here. So we have our pipes. Let's see, the pipes we put little arrows on the pipe, show the direction they're flowing. We have spot heights with elevations. We've got your trees showing you which are deciduous and which are coniferous.
Okay.
And if I click on our happy little pipe, we'll see that we have indeed gotten the invert elevations and the crown elevations, the slope percent, as well as we've also extracted these things named after some interesting people that I have no idea what they do, but they seemed important, so I threw them in.
Okay.
So that essentially is a Civil 3D transformation. So it's not dead simple. There possibly may be a little work involved, but as you saw, the workspace was not really that complicated.
Right. So we're closing in on the last couple demos. Mark, I think you're going to do some dog parks for us now. Is that right?
I am, yes.
And your mic is a little bit far away, Mark, I think.
Oh, sorry.
There we go.
You're right.
Okay,
I pushed my mic up. Okay, so one thing I wanted to mention, a lot of people had asked about missing coordinate systems and what you can do about that.
Yes,
and we do have a bunch of transformers that will handle that when you're converting from CAD to GIS. So, I mean, there's the basic offsetter, so you can just offset your data if it's on a certain grid. You could offset it and scale it if you know what the scale factor and offset is for a small local grid. There's the affine warper, where we can say, well, let's warp the data. If we've got a set of control lines that says where the data should come from and go to, we can warp the data like that. If you know what all of these coefficients are, you can just feed them straight into the affiner. There's a local coordinate system setter, which says, oh, okay, I know it's in a local coordinate system and these are the parameters. I'll set it like that. And so, yeah, there's several ways that we can cope when the data's coming in, but it doesn't have a coordinate system, and you need to get it into the right position with a coordinate system. So, just wanted to mention that.
Very good.
Okay, so what we're going to look at now is doing a GIS to CAD translation. And so what we're going to do here is generate some blocks as well. So I'm going to generate a new workspace. We're reading from shape, and I'm going to read from 2 different shape files. There's a park polygons and a dog off-leash areas. Even though it's called areas in the file name, these are actually point features, and they're the ones that we'll create blocks out of. And we're going to write to AutoCAD, DWG. And let's find somewhere to put that. I'm going to go and put it back in my presentation folder because that just makes sense, and we'll call it parks.dwg. And one of the things we can do when writing out AutoCAD is we can select these parameters and we can say, well, which release do we want to write it to? We support quite a lot of these by the look of it. We're going to go with 2013, and we've got a template file as well. So I'm going to browse and find a Parks template, and the template's got the block definition in, and I think you can have color and line style definitions and things like that that you can use from there as well. So this is just going back to the plain generate workspace dialog. We said we read it from shape, we're writing to AutoCAD, and I click OK, and we get this little workspace comes up. And let's just get those into position. Okay, so we have the park polygons themselves, and we have the dog off-leash parks. So some of the parks have got dog off-leash areas, and we're going to flag those up with a little block. And the transformer we'll use for that is just called a DWG styler, and it's a very, very useful transformer. We can open that up, we can set colors. I'm going to pick that template file again, and in this case we don't want to set the color, we want to set a block. So let's put that block, and we're going to pick the block, and that's browsing through the template file looking for all of the blocks in there, and it's picked the one out with the dog park. And we can set this to be a scale factor instead, or whatever we like. We can change the size of that dog and the rotation as well. One of the nice things about FME is you can set all of these from attributes. So, for example, the scale factor, if we had an attribute that was, well, there you go, the hours, so the number of hours that the park is open, we could scale the block by that number. So the longer the park was open, the bigger the dog block would be. Things like that we can do very easily. But for now we'll keep them all at the same scale. And we can do very similar things with the polygons. We can open that up and we can say, well, let's change it to be a green color with the DWG styler again. Area features, we can say, is it going to be a solid fill? Is it going to be a hatch with a fill pattern, with a gradient? We can do all sorts of different symbology, if you want to call it that, on that output. So we'll just say, let's see, yeah, so we'll go with that one and see what we get. So we'll just run that now, and that's basically just reading from shape, styling the data, writing it out into AutoCAD. We'll open the containing folder. Oops, I've lost my... There we go, and it is called parks.dwg 1053. That's the one it's just written. And I have DWG TrueView, so we can just open that up. And let's see. Libraries, documents, presentations. Let's see, where are we? AutoCAD. And it was called parks.dwg. This thing's just popping up to say this file was generated by someone other than Autodesk, which is true. We created it, so we know that's okay. We can just continue opening that. And we have the red colored blocks, and now how do I turn that off? Layers, because let's see, can we turn... We'll turn the polygons off. There we go, and we should be able to see the dog layers now. I can zoom into that, and we've got the little doggy block that appeared in there that we created. So those are the layers. You just can't see those because they're turned off. They're underneath the polygons, and I'm not sure if there's a way we can drag one above the other. So that's what we've got there. So yeah, that's a pretty simple method of converting GIS data into CAD, and just really the key transformer there is that DWG styler, which creates so much of the thing we need. One other thing I meant.
Okay, sorry, Mark, go ahead.
Sorry, one other thing I mentioned, there's a question I saw, can you round trip the data? Because if you've got a spline or a NURB or whatever you call it in your CAD and you convert it to GIS and it might get stroked because the shape won't support that, for example. We do have a transformer called Curve Fitter. I think that will convert it back into a curve at least when you're coming back from GIS into your CAD. So you can round trip that way.
One other interesting thing you can do about round tripping is that CAD data tends to have a lot of information, especially symbology and what we call format attributes, which are kind of structural attributes on the data. And the CAD tends to have an extreme amount of them. I think between MicroStation and AutoCAD, they account for over half of the format attributes in all of FME total. There are a couple of store transformers called the attribute packers. I think the most useful one is the attribute JSON packer. And I've had good luck with that in packing all of your format attributes into a single blob and then storing that into your geodatabase. And then so you only have a few attributes in your geodatabase that you're interested in, plus this blob that
the symbology basically.
Yeah, it just kind of sits there. And then when you round trip it back to the CAD, you essentially unpack that blob into all of the format attributes again, and you can get a pretty impressive round trip without having the overhead of like hundreds of attributes being necessary in your geodatabase.
Excellent. So Dave, we're down to the last 3 minutes. This is like the grand finale of the fireworks display. We're going to, we know we've covered a lot of ground, and Dave's going to finish up by doing a whirlwind. This is sort of FME 2014 sneak peek. You're going to show us Revit to GIS in 3 minutes.
Oh my goodness. Okay, we'll try to make this fast. Now, Revit is a bit different from all the other formats in that we don't actually read the Revit data directly.
It's impossible. There is no library.
Yes. Yeah. So what we've done is we've created a little application that I'm going to show you that sits within Revit and writes out to an intermediate format that we can then read in FME.
So now, Revit dumper, basically.
Yeah. So now, if you install FME after Revit, it should normally install that into Revit. But if it hasn't done so, if you go into FME 2014 Utilities and into the FME Integration Console, you then see that you have the option to extend Revit with the FME Revit Exporter for Autodesk.
Excellent.
It's got a very long name.
Yeah.
But mine is already extended, so we're good to go. Now, if you pop into Revit, I'm just taking one of the sample data sets that comes with Revit. You have the options under add-ins here, external tools. Oops, hang on.
You can't be in the 3D view.
Yeah, I'm not sure why that
is. They told us at AU that that's intentional. I'm not sure why, but anyway.
So in a non-3D view, you have external tools, the FME Revit Exporter. And this comes up, and it's very similar to the IFC exporter, but it adds some extra information, and it writes out to a different format. So you have the basics things you can do here. There's a setup, which I recommend using. We pretty much just have the basic IFC going in as a default, but generally I like to grab a whole bunch of other stuff as well. The internal Revit property sets. More importantly to what I'm going to show later is the 2D plan view elements. So Revit stores 2D data and 3D data all in the same file, and we can use that to our advantage. So I'm going to grab these, go OK, and normally I would export, and away we go. But this is a large data and data set, and it takes time to do that. So again, with the cooking show theme, we're going to skip to the next step.
And while Dave's skipping, I'll just say if some folks have to leave, we're only going to do Revit from here on in, so thanks very much. And there's a few other things we'll be following up with you. If you can stay and watch the exciting reveal, please do.
Okay, so now I'm going to quickly add a Revit reader. And you'll notice about the Revit, I'm not going to add the data set, but the Revit reader, you click on the parameters, and it comes up with this interesting thing called element type. And you click on that element type, and it comes up with a list of options. And what we've done is Revit is an extremely complex format that holds multitudes of data. And what we're trying to do, instead of giving you a raw dump of that data, we're trying to do a little bit of pre-processing for you to make this easier, so you can pick the type of translation you want for your scenario without having to do a lot of work, because we've pre-done it for you. So in this case, I have a couple of them: a 2D floor plan extraction, 3D Revit model with textures, building envelope, building hosts, etc. And we will be continuing to add to these, and we'll probably have a raw Revit dump for those who do want to sort of roll their own data manipulation from the raw Revit data. So I'm just going to show you the options there. Now, again, I've got this Revit already added, and this one here I've essentially used the 3D textured. So that's going to extract a 3D textured model for me. Now we're going to Geodatabase, and some formats like SketchUp can handle lines and faces in their models, and they're quite happy. Revit has these. SketchUp can handle them. I think Collada can handle them as well, but Geodatabase cannot. So the first thing we do is we use this nifty new transformer called the Geometry Part Extractor, and this is a very important geometry tool, and it lets you create a query on your geometry. So I basically said, this part of the geometry name is body. Now in Revit you have different names for the different types of your geometry. 2D stuff is annotation or axis. All the 3D stuff is named body.
Okay, so I'm fishing out only the 3D.
Yeah, I'm only interested in the 3D, so I'm going to grab the body type of the feature. And then the action, we have two different actions. We can extract or remove. Extract means you want that. Remove means you want to expunge that from your data because it's going to cause nothing but problems. So in this case, we want to extract. Now, the other thing is what comes out with the body, unfortunately sometimes, is null geometry as part of that. And so what we want to do is get rid of the null geometry as well, because that makes Geodatabase a little queasy as well. So the next thing we do here is we have a geometry coercer, and now some of the body geometry in Revit comes out as solid, constructive solid geometry and solid models. Again, we want to go strictly to a surface-based model
for ArcGIS.
For ArcGIS. So we use a geometry coercer to coerce the solids to a FME composite surface. And what this will do is take any solid and just take its bounding surface and extract that for you as well. So the fair bit of geometry manipulation.
So once you've done all that,
once we're done all that, it goes out to a simple geodatabase, and I'm going to show you the results. I just loaded that into ArcScene, and here we have a model of the building. So if we look at Revit, we go back to our. Okay.
How do you get to 3D?
Yeah. Okay. Well, we trust you all that you remembered what it looked like when I first brought it up, and here it is in 3D. You can see that you're getting proper texturing. Now we don't give you the photorealistic textures. Those actually don't get exported with the Revit file, but we do get the procedural color textures, and it handles things like transparent glass, and so you have full alpha and everything.
And we only took the outside of the building too. So if there was plumbing in there and stuff, we would be throwing that away.
Yeah,
because the GIS doesn't need it.
Yeah, we did grab internal walls and furniture and stuff, and I think if I scoot through.
But all that stuff is possible to get rid of.
But we're running out of time,
yeah,
so I won't give you the grand tour of the
big building. And the last thing is
you
got floor plans for us.
Yeah, and the another way of another element that I use a 2D floor plan, and this is a bit simpler. It breaks everything down into its furniture elements, columns, stairs, flow terminals, etc.
Yeah, you just bring it
and I
straight
just
across.
bring it straight across into Geodatabase.
Flow terminals have to do with water?
Water and, weirdly enough, electricity.
Okay, wow.
So sinks and taps are both included. Don't hook up the wrong one. So, and now and just showing you the Arc map, that's the output of the floor plan. So you can see all the walls. Right. You notice that you get the 2D symbols here, and this is the thing that why I set the 2D symbols in the Revit is instead of having the 3D model of the trees, it gives you a 2D symbol of the trees.
Okay.
You get doors with their little swing arcs. You get the proper representations of the furniture. So anything that has a 2D representation as well, it will use the 2D representation, which tends to look a lot prettier for your output. So that's just a quick example of some of the things you can do with our Revit export.
Okay, so I think we'll finish up there. Mark Ireland, we got a couple slides just to show the last people that are still there. Thanks. We know we're running a tad late, but let's just finish up. And I've just made you presenter there, Mark. You have to accept though.
Yep, you should see my screen now. Yep.
Yep. So just whip through to the very end there.
Okay.
You get all these demos. Yeah, we'll do this last poll, and just to see now that you've seen all this stuff, what would you like to exchange data with? And I threw something else interesting in there to see if any of you are interested in the 360 family of cloud services. And so far I can see how many are. Oh, no, there are some. So that's great, because that's an area that we're looking to expand. And those of you answering yes there, I may be in touch, following up with you in the weeks ahead to find out more about what you'd want to do. So really appreciate you sticking with us this long.
One thing I'd like to add is when we're doing the Revit import, I pointed out that we are creating these elements for you to help structure the data for different scenarios. We would really, really, really like your input on scenarios that you'd like to see with the Revit data output. Just send an email to support@safe.com, outline your scenario, and we really, really want to know that information because we need to know what you're going to do with the data.
Fully a quarter of you said Revit, so we're really interested in your scenarios. We know that we're taking our early steps into this, and we expect over the next year to do a lot more. We'll probably do a webinar just on Revit sometime in the many months ahead. But we do want to know okay, now that we can actually have a pathway from Revit to wherever, one of those things wherever being ArcGIS, but could be anywhere, what is it that you'd like to be traveling down that road? So we'll look forward to that. So again, just the last couple of things. This is recorded. We'll be sending you a note about that. We've got some other webinars coming up. We're hitting the road in April, going to, I think, 17 cities in North America and another probably 20 or so worldwide. But we're coming to Vancouver in June for a big week of FME here in Vancouver, so keep that in mind. They're in your budgets as well. Will be very good. Lots of training, lots of learning.
Absolutely.
The training is going on right now next door for the intro course. Those happen all the time, and it's free. Go to safe.com/training for that. Tomorrow, if you want to do raster, sign up now. You can still get in. Dave, are you teaching the raster tomorrow?
Oh, no. Oh, well, I'm actually I'm going to be helping out with the questions.
Okay, wow, yeah. I can get a good jump out of you there, too.
That's right. Ryan Craig is doing that. Yeah.
Oh, another, okay, yes. The guy who's in the picture, actually.
That's right, yes.
But that isn't Dave beside Ryan.
No.
Okay. All right. So let's keep going. And I think that's probably about it. We have a number of ways you can touch base with us. Thanks, folks. We know we've run 5 minutes late. We apologize for that. But there was a lot when it comes to AutoCAD to show you. We hope you found this useful. We look forward to interacting with you more in the future. And this is Dale signing off from beautiful and slightly snowy Surrey, British Columbia.
Goodbye from Dave as well.
And from Mark, goodbye.
All right. Thanks, everybody.